Okay, I realize some of you might not be done yet, but let's go ahead and see what we have here. For number one, finding the area, the first thing we need to do is find those missing dimensions. So to find this dimension, we can only use other horizontal dimensions. That would be the 8 and the 18. Well, those have to add up, so that would make this 10 inches, so that 10 plus 8 equals 18. Going the other direction, to find this dimension, I can only use other vertical dimensions, which would be the 10 and the 14. Again, those have to add up, so that makes this piece 4 inches, because 4 plus 10 makes 14. Now to find the area, we have two possibilities. I could fill this in, find the big rectangle, and then subtract back out the little one. That would work, actually probably the simplest way of doing this. But most people would approach this as cutting that off and doing two rectangles that we're going to add together. Rectangle 1 is 10 by 18 or 18 by 10, however you want to view it. 18 inches times 10 inches is 180 inches squared. And rectangle 2 is 8 by 4. So 180 plus the 32 adds up to 212 square inches of area. Number 2 here. Well, we again have a couple of dimensions we need to find. The easiest one to find is going to be this one here, the vertical. That's just going to be these other vertical dimensions added together. 2, 6, and 8 add up to 16 inches. This one here, however, is going to be a little tricky to find. Actually, that's not that. This one down here, I should say. Because we can only use other horizontal dimensions. Well, if I have this 8-inch piece. If I knew the distance across here, those two would just add up to give me this one that I'm looking for. So let's see what I can do to find this dimension. Well, that would be the same as this dimension up here, and I see I have the 4 and the 10 that are both horizontal. This has to add with the 4 to make 10, so this is 6 inches, which means this is also 6 inches. So then down here, 6 and 8 make this 14 inches. Now we'll go ahead and divide this up. I'm just going to cut it across right where I had those little arrows. This top piece here is 10 by 2. 10 inches by 2 inches, making that 20 inches squared. The second piece here is 6 by 6. 6 inches by 6 inches, making it 36 inches squared. And finally, the third piece is 14 by 8. 14 inches by 8 inches is 112 inches squared. If I add that up, I get 168 square inches of area. Number 3, we're asked to find the volume. So remember, when we find volume, we're looking at the area of a base times the height. But the height here does not go up and down. This is actually the height here, which is labeled as 10 inches in this one. Because the reason that is the height is because this would be your base. Remember, the base is the shape that has to be the same on opposite sides. This shape here, I can move it over, that'd be the same shape on the opposite side. That has to be the base. And then the height has to be the distance between the base and the opposite side that is the same. So that's how the 10 becomes our height. So we need to find the area of this base right here in blue. A with the little b by it stands for area base. Now to find that, I need some missing dimensions here. This one here is going to be 7 inches. How do I get that? Well, this is 5 inches. The 5 and the 7 have to add up to the 12 because those are my vertical dimensions. This one here ends up being 11 inches. Well, how did I get 11? Well, this is 20 here. That just moves over. The 9 and the 11 have to add up to 20. Now I'll go ahead and I'll cut this. This rectangle here is 12 by 9, giving us 108 inches squared. The second one here is 11 by 5. Giving us 55 inches squared. Or 163 square inches. Now, to find the volume, you take that area of that base, 163 square inches, times the height. Remember, the height up here was the 10 inches. Get that our volume is 1,630 inches cubed. Remember, volume is always cubic inches. It's 3 dimensions multiplied together. Any questions on any of those? So the purpose of doing all those yesterdays was to apply formulas. And we discovered a few formulas. One was the area of a rectangle. Which gave us the formula that area is length times width. And we were just taking our rectangle from our figure, from our drawing, and putting the length and width in. Maybe having to divide complex figures up into rectangles. We also found the area of a triangle. The area of a triangle was based off of what we called that related rectangle. Length times width divided by 2, or 1/2 times the length times width. Other ones we saw was volume. Volume was the area of a base times the height. Now, one thing I should point out, I used it yesterday, but I didn't talk about it much. This here, that A with the little b. The little b is called a subscript. In that subscript is telling us that that is a special type of letter A. We saw that subscript a little bit back last week when we did some of our homework problems had resistors in them. And we saw this as R1 and R2 and R3. Well, that subscript, that 1 is telling me that this R is different from this R because this is the R2 and this is the R3. Those 1, 2, and 3 that are not having any numerical value, they're just signifying that those are different resistances or different R's. This is the first resistance, or resistor number 1. This is resistor number 2, or the second resistance. And this is resistor number 3. So that they are different. We try to use letters that have meaning, like R for resistance or resistor. But in order to keep that straight, if we have more than one resistance, we have to have a way to separate them. So we might use R1, R2, R3, or RA, RB, RC, something like that. That subscript is used to signify that is a different variable than the other R's with a different subscript. So now we're going to look at some other formulas today. One formula I want to look at is the formula for work. Work is defined as the ability to apply a force through a distance. or to apply a force to move an object, change the state of an object. So the amount of work done is equal to a force applied times the distance moved. And now again, we usually write that as just W equals F times D. So let's say that I am going to carry shingles up a ladder, a bundle of shingles. Let's say that bundle of shingles is 40 pounds. And I'm going up a roof that is 12 feet high. Now we're going to ignore the fact that we're going at an angle. We're just lifting them straight up to the roof because that's really the work that's being done against any force. So the amount of work that's done here is 40 pounds of force times 12 feet of distance. 40 times 12 is 480. But then we also, remember, when we multiply, we combine the names. For areas, it was inches times inches to be square inches. Here the units are different. It's pounds times feet to become pound feet, or foot pounds is the more common way of listing it. So the amount of work done here is 480 foot-pounds of work. Now we might run into a formula for current in a circuit. The formula for current, we use I for current. The reason we use I for current is C is used for a lot of other things. We have C for capacitance. I can't think of the others right now, but there's a couple others that we use C for. So we use I for current. Current is equal to voltage divided by resistance. So if I have a circuit that has a 4 ohm resistance, that's R equals 4, and a voltage here, 24 volts. Well, my current can be found by putting 24 in for the volts and 4 in for the ohms. So I divide. 24 divided by 4 is 6. Now this part I wouldn't expect you to know yet, but those of you in automotive, you are going to see this in your DC electrical class. A volt divided by an ohm is an amp. I'm going to write out the word amp for now. Other formulas we might use. We have formula for power in a circuit. This one's a little bit more complex. The power in a circuit is equal to the voltage squared divided by the resistance. So let's look at that same circuit we had. This had 4 ohms of resistance and 24 volts of current of voltage. To find the power here, voltage squared will be 24 volts squared over 4 ohms is my resistance. 24 squared is 576. Now we have to also square the volts. We haven't gone over squaring with names yet, but we do have to square the names. That's volts squared over the 4 ohms. Now 576 divided by 4 is 144. But we also have to divide the units. Now again, those of you in automotive will learn this later in the semester in DC electric, but a volt squared divided by an ohm is what we call a watt. Let me write that out a little clearer. An alternative version of power is power can be listed as current squared times resistance. So if I have a circuit here, I'm going to change up my resistance now. Let's make that 3 ohms just to be a little bit different. But now for this formula, I need to know how much current is flowing. Let's say that we have 4 amps of current. So my power is going to be the 4 amps squared times my resistance of 3 ohms. Well, 4 amps squared, 4 squared is 16. Amp squared is just an amp squared. Now I multiply. 16 times 3 is 48. Well, again, you'll learn in DC electric, for those of you in automotive, an amp squared times an ohm is also a watt. So it's 48 watts. I don't expect you to understand how to combine some of those units in the electricity for right now. I would expect you to be able to do feet times pounds is foot pounds, or inch times inch is square inch. But I don't expect you to know that a amp times an ohm is a volt, or an amp squared times an ohm is a watt. I would not expect that at this point. One that might be a little more familiar to you. Let's say you travel 354 miles, 7 hours. I want to know how fast you are going. Well, this is a velocity problem, a speed problem. Velocity is equal to distance traveled divided by time. Now, technically, velocity is displacement divided by time, not distance. But the simple version is to do distance divided by time. So in this case, now it's a little confusing because V is used to abbreviate volume. It's also used to abbreviate velocity. Our velocity is equal to that distance of 354 miles divided by our time of 7 hours. So we combine counts. 354, oops, I did that wrong. It's meant to have 364 here, not 354. I'm going to change that number. I'm going to make sure give you time to change that in your notes. I changed that to 364, not 354. So I changed it down here as well. I was not trying to give us 50.571428.6 or anything like that. I was trying to keep it out to an even number. So it should have been 364. I just wrote it down wrong. So 364 divided by 7 is 52. But remember, we also have to combine the names. Miles divided by hours is just miles per hour. Another formula we run into, we talked about areas yesterday. Let's talk about, first of all, what is a trapezoid? A trapezoid is a four-sided figure, has 4 sides, and 1 pair of parallel sides. Most of us are used to seeing a trapezoid something like this. But a trapezoid could look like this. Those sides are parallel. So let's stick to that main version of a trapezoid and talk about finding the area of a trapezoid. Well, really, the only shape that we know how to find the area of is a rectangle. We did the formula for a triangle, but we found that formula for a triangle based off of that related rectangle. Well, the same thing happens for a trapezoid. We look for a related rectangle. Now, the problem is with the triangle, it was pretty simple. If it was a right triangle, you just flipped it over and put it together, you had the rectangle. If it wasn't a right triangle, you just cut it in half and flip the pieces over, and you had a rectangle. That triangle is exactly half of the related rectangle. For a trapezoid, our related rectangle is not quite as simple. I'm going to throw some links in here. I'm going to call this 18 inches there, and let's call this 32 inches across here. And then I have to have an altitude or a height, which is the distance between the parallel sides. I'm going to put that in as 15 inches here. To find my related, or to create my related rectangle, I should say, I'm going to go halfway down one of these sloped surfaces. So that'd be halfway down that slope there. Then I'm going to cut this off going down. Square. At a right angle, in other words. That little piece I cut off flips up and it fills that in perfectly. I just squared off that end of my trapezoid. On the other end, I do the same thing. I go halfway down that sloped surface. I cut that little tip off square at a right angle, and that little tip flips up perfectly to fill in there. I now have a rectangle. The width or the height of the rectangle is still just the height of that trapezoid. The length of my rectangle here is the tricky part. Well, I know the length is longer than these two parallel sides, by the way, are called bases. Obviously, the two bases are not the same size. But the length is between the short base, the 18, and the long base, the 32. In fact, it's exactly between them. It's the average of them. Well, how do I find the average of a number? Average is found by adding the two numbers together and dividing by 2. So I'm going to take my 18 inches and my 32 inches, and I'm going to divide by 2. Well, 18 plus 32 is 50. Divided by 2 is 25. So this length here is 25 inches. So the area of the trapezoid is equal to the area of that related rectangle. So that related rectangle is the 25 inches times the 15 inches, which is going to give us 375 squared. Well, we need to come up with a formula for this. The 15 here was just the height of our trapezoid. The 25 was the little base plus the big base. So I'm just going to do little b plus big B divided by 2. It was the average of those two bases. The area of a trapezoid is the average of the bases. I'm going to put these in parentheses times the height. So even if we have a stranger trapezoid, like this, these are the bases because these are the sides that are parallel with each other. Let's say I'm going to call this 6 inches here. This down here we're going to call 20 inches. Now I still have to have the distance between the bases. Because they don't quite line up, I can extend this one to find that distance. Let's call this distance here 12 inches. So the area for that trapezoid, I'm going to plug into my formula. I have my little base, which is 6 inches. My big base, which is 20 inches. Divided by 2, that'll be in parentheses. Times my height, which is the distance between bases, which is the 12 inches. So now we can go ahead and calculate this out. At this point, it's just an order of operations problem. 6 inches plus 20 inches is 26 inches. Remember, when we add, we combine counts and we keep the same name. Then we're going to divide. 26 inches divided by 2 inches is 13 inches. I don't need the parentheses anymore, so I can take them out. And finally, I have 13 inches times 12 inches is 156 inches squared. We do have to multiply. Since we're multiplying there, we do have to combine the names. Inches times inches is square inches. Now, these formulas are out there for all sorts of different things. We can have formulas for finding the displacement of a car motor, formulas for finding the amount of feed and the amount of protein a cow needs in her diet to continue its current production levels, and all, or to maintain body mass and continue production levels, I should say. There are formulas for all sorts of things, and the key is just to plug in the numbers. I mean, I can have some pretty wicked formulas like, I'm just going to make one up here. P is equal to 2m minus 5h over t. And I could ask you to evaluate that for m equals 7, h equals 8, and t equals 20. So to do that, I replace each of the letters in my formula with the values that we specified for them. So P equals 2m. Now remember, that stands for 2 times m. So when I place m with the 7, that's 2 times 7. Minus 5h. Again, that's 5 times h. So I place h with 8, so that's 5 times h. Over or divided by t is 20. Now again, this is an order of operations problem. Technically, this is serving as an enclosing symbol here because it has more than one thing to do on the top of that fraction. So I have to do the 5 times 8 there first, which is 40. Now, on the realistic side, a lot of people would have done the 2 times 7 first and then did the fraction all at once. That's not going to change your answer. That will still work. I'm just being very technical about how I follow my order of operations. Now, there's no more enclosing symbols. There's no exponents. So we're going to multiply and divide going left to right. 2 times 7 is 14. And then I do have the division. 40 divided by 20, which is 2. Of course, then the last thing we have is the 14 minus 2, which is 12. So P equals 12 in that example. Anybody have any questions? So if you've noticed in Blackboard, Quiz 2 is out there. Quiz 2 is on the order of operations. And areas and volumes. Be very careful with all the problems. This is a quiz that students tend to struggle with because there's a lot of different steps. So make sure you're careful with it. Take your time. That is out there. That is due by noon tomorrow. So by noon, September 4th. Then homework on our new stuff here is on page 22 in the book. 1 through 29, the odds. It's just applying formulas. Also, a little bit of a heads up. We are closing in on the end of Unit 1 already. In fact, if all goes well, we should finish Unit 1 next Tuesday, which means we're looking at Unit 1 test next week, Wednesday. I will post that out there on Blackboard sometime Tuesday afternoon. And what I'll do is I will leave that test up there all day Wednesday. So anytime during the day Wednesday next week, as long as the schedule doesn't change, that's the plan for now. Anytime during that day, you can go to Blackboard, just like the quizzes, download the test, complete it, upload it back in for me to grade. I will be in class next week on Wednesday. Just in case you have any questions, you're welcome to sit in class on the network and work on the test with me here, so I can answer any questions for you. But I'm not going to require attendance on that test day. On test days, doing the test is your requirement for the day. Okay, with that, we have 15 minutes left. Normally I give you 10 or 15 minutes of class time to work on the quiz. So that's why I'm ending a little bit early today, is to give you time for the quiz if you need to do it now, or to make up the time that we would have taken out of class for it. If you want to stay on the network and start the homework, I'll be on the network to answer any questions you might have. Otherwise, you are free to go if you choose to.